5.2. Oh, I grabbed the shitty pins that don't show up that well. I put that down and grab my ethers. We're doing 5.2, and this is on dependent events. Nope. It's on the addition rule and complements. And compliments is not spelled like you would spell compliments, like, damn, you look pretty snazzy today. I like your outfit. Compliments, that way it has an I right here. Our compliments has an E. So, I'm going to make an assumption, may or may not be true. Fucking lie to me, John Luca. I swear to God, I'm gonna throw something heavy at you. Has everyone in here played Monopoly?
Yes.
Has anyone not played Monopoly? You haven't played it or you have played it? Okay, good. So now I can talk about examples with Monopoly. If you haven't played Monopoly at home, sorry about your luck. So let's do an example from Monopoly. Now, I don't know the way your family plays it, but we like to use free parking as a collection for all the fucking taxes paid. We collect all fees and taxes there, and whoever lands on it gets it. It's like, it's a prize to land on free parking. Do you guys' family do that?
Wait, the one with the like the red thing on it?
It's got a fucking car on it. It says free parking.
No, I'm thinking of the thing where it's just like go or something like that. You collect like I think 500.
That's in the exact opposite corner.
That's.
Go is the start square.
Yeah, once you pass that, don't you get money?
Yes, I'm not talking about that square.
Okay. I just get happy when I get free parking.
Bless his heart. You are one of my favorite students ever. I'm gonna tell everybody about the fucking support. I won't use your name, to be fair, but I'm gonna tell all my students about the student that didn't know what support meant.
I think they'd be more confused if you use my name. I'm not gonna lie.
Yeah, but in terms of anonymity, which is a fun word, I like the word anonymity.
Can you say that 5 times fast?
Anonymity, 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 anonymity. Now, the word I can't fucking say one time fast is rural. 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 R-U-R-A-L.
That one's a funky word.
Rural. I fucking can't do it. And later on in this class, rural shows up in one of the problems, and you will fucking listen to me mangle it like 2 or 3 times, and eventually I just switched to saying country. Like, rural home is a country home. You're out in the middle of nowhere. All right. Free parking is like collect a prize. So this is the scenario that you're in. You want to roll an 8 to land on free parking. And win money, or you want to roll doubles to keep going. So let's look at the ways we can roll an 8. I could have 2 and a 6, because you get 2 dice when you throw, remember? I could roll a 3 and a 5. I could get a 4 and a 4. And though it looks the same, it's not. I could get a 5 and a 3. And I could get a 6 and a 2. If you had your dice where one of them had like red dots and the other had blue dots, you would see that they are 2 different outcomes. When you use white dots with black pips, that's what the mark on a die is called, is a pip. There's your fucking Jeopardy term for the day, P-I-P, pip. So, those are the ways to roll an 8. How can we roll a double? We can do 1 and 1. We can do 2 and 2. We can do 3 and 3. We can do 4 and 4. We can do 5 and 5. Or we can do 6 and 6. So let's look at the probability of rolling 8. The probability that my roll equals an 8. I'll just call it P8. Are you guys okay with that? Rather than saying roll equals 8, we just do P8. I see a total of 5 outcomes up here. For 2 dice, there are 36 possible outcomes. I'll actually show you how to get that when we do 5.5. It's called counting methods. The probability of getting doubles, I see 6 different methods, so 6 out of 36. Everyone with me so far? So, and then let's look at the probability of getting 8 or doubles. Which ones work? Well, I could have all the doubles, any of the doubles work. That's 6 different outcomes. And then I have a 7th outcome here for an 8, an 8th outcome, a 9th outcome, a 10th outcome. The 4 out of 4 is already here, so I'm not going to include it. There are 10 ways to get an 8 or 36, or 8 or doubles. 10 out of 36. And that's what we want, 10 out of 36. Wouldn't it be convenient if we could just add? It'd be nice if we could add the probability of 8 plus the probability of doubles. But if we do that, we have 5 over 36 plus 6 over 36 is 11 over 36. We have one too many. We have one too many outcomes that way when we do it that way. And look at that. We crossed off one of the outcomes when we did it by the long way. It was the overlap. It was the outcome in both categories.
Because we already have a double.
Yeah, we already had the 4 and the 4 once. So let's look at a general formula for this when everybody's writing along. Are we ready to switch the page? Everybody looks that. All right, so the general addition rule for probability. The probability of event E or event F equals the probability of E plus the probability of F minus the probability of E and F. That is the general rule. If we made this apply to our doubles, the probability of 8 or double equals the probability of 8 plus the probability of double minus the probability of 8 and doubles. I'm gonna put a box around the actual equation so it pops out. So we saw this was 10 out of 36. Probability 8 was a 5 out of 36. Plus doubles was 6 out of 36. And there was only one event that was both 8 and doubles, the 2 4s, minus 1 out of 36. So when you're combining fractions and they have a common denominator, oops, not 56, 36, you can use the common denominator and just do the adding and subtracting of the shit on top. And 5 plus 6 minus 1 is in fact 10. Now, a lot of teachers that teach stats don't start with this rule in the addition rule category. They start with the one that's going to show up next. But the one that shows up next isn't always true. This equation is always true. Sometimes, and the reason why this is helpful is sometimes you can't just draw the pictures and go which ones and just count up the ones. The dice ones is easy. I can't do this with the pigs. So like being able to have a formula that works all the time is helpful. Let's go back and let's look at another Monopoly scenario. What about?
Is P always 1 out of 36? Or for in this scenario, 1 out of 36?
Is P what?
Oh, wait, never mind. I see. Because you added 8 and doubles. So that's basically 1. Okay.
Yeah, this one represents the 4 and the 4. There was only one outcome out of 36.
Okay.
We did these three on the other page.
Yeah.
Does that make sense?
Yeah.
What if we wanted a 3 or doubles? We already wrote the doubles. The probability of rolling a 3 is a 1 and a 2 or a 2 and a 1. So the probability of a 3 or doubles is these 2 plus the other 6 is 8 out of 36. And if I wrote it like that formula up there, it's a plus. That's double. Minus probability of 3 and double. we have 8/36 equals 2/36 plus 6/36. And this is 0. There's no way to have a single roll be both 3 and doubles, because it's an odd number and doubles are all even numbers.
So if you don't have doubles, then it's gonna automatically be 0.
Yes, the overlap category. So when there is no overlap between the categories, or events, we call these events disjoint events. And the equation we had above simplifies. The key here is to know that disjoint means nothing in common. In outcomes. I think almost every single textbook that has probability starts with that one and goes to the other one. And I always think that's really stupid to do like the easy one and then go to the hard one, because then students always want to use the easy one and they miss every single hard one. If you start with the hard one, and let's face it, it wasn't that hard to be able to subtract another number. This one always works. When they're disjoint, that last one is 0. For disjoint events, probability of E and F equals 0. I think that's worth noting down with the E and the F. There are problems in the homework that are going to say, like, what's the probability of getting a jack or an 8? There's nothing in common there. Eventually, they'll do something like jack, 8, or a heart. So just be paying attention for the overlap. Make sure that if there's any overlap that you subtract it. That's the only complicated thing in this section. This entire section could boil down to that. But we'll look at the complement rule real quick. It's really short. I'm already 2/3 of the way through the lecture page that I wrote to teach on this topic. It's not a long topic. I'm not wearing my glove and I'm getting fucking ink everywhere. I don't know if you guys can see it. I gotta show up. It's fucking red all over the ink. Like, the fucking red pin, the cap kept coming off, getting all over my hand. Motherfucker, I don't know how to put a goddamn glove on. All right, so let's look at complements. Complements. The complement of event E denoted E with like a C as an exponent. That's how we indicate the complement of E. This contains all possible outcomes not already in E. Let me give you an example. The probability of getting a heart, that's going to be my E. Well, heart is E. So this is like my probability of E. All possible outcomes not in E means getting a diamond, heart, or not heart, fuck, I already fucked up. Diamond, club, or spade. That's going to be the probability of E complement. E is drawing a heart, so E complement is drawn any other suit. Does that make sense? Does that give you a feel for how complements work? So what we got going on with complements, the formula, the magic formula here is, let's see if we can intuit. The probability of getting a heart, there is 13 cards out of 52. The probability of a diamond, club, or spade. Each suit has 13, so there's 39 cards out of 52. With that in mind, the probability of E plus the probability of E complement equals what? What?
Oh, one.
It equals 1, right? If I do that here, this is like doing the probability of a heart plus the probability of diamond, club, or spade. 13 over 52 plus 39 over 52 is 52 over 52, which equals 1.
Is it only when you have like P of E, so it's like it's only asking for one specific and then it leaves out all the other ones out, and so you have your P of E with the complement?
The E with the complement is every other possible outcome.
Oh, okay.
So like if we had if E was drawing the ace of spades, E complement is all cards that are not the ace of spades. The more useful form of this equation is this. If I do a little bit of algebra and I subtract the P of E over, I have the probability of the complement of the event equals 1 minus the probability of the event. That is the more useful form of the equation. And I will show you that when you guys are ready. Chapter 5 does not really anything to do in StatCrunch. This is all gonna be calculator work for chapter 5. You can do calculator shit in StatCrunch, but it's not easy, it's not really intuitive, and it's so much faster on any other calculator. Okay. Before I continue with that, we had said disjoint events, they don't have anything in common. They don't have there's no outcomes in common. This is kind of like our complements. Disjoint events are also called mutually exclusive events. That's another name for it. And sometimes you may not realize you have it, but if you have two mutually exclusive events, and the probability adds to 1, they are complements. They have to be mutually exclusive or disjoint. They can't have any single one outcome in common, not even one. Where do we use this, where do we use probability of event complement equals 1 minus the probability of event? How is that useful? Let me give you an example, a scenario. We have 18 girls and 12 boys. And we pick 4 children. What is the probability?
You said 6, but you wrote 12, do you mean 6 or 12?
Let's go with what I have written down. I don't remember saying 6.
I heard 4. Oh, 4 children, just kidding.
What is the probability of picking at least one girl? Let's say we pick them at random. Picking what? At least one girl out of 4 kids. The probability of picking a girl, just one, is 18 out of 30, yes. But the at least is throwing it off here. What does this mean? Well, how many girls can I pick?
18. Or you can only pick 4.
I can only pick 4, so what are my possible outcomes? Well, I could pick 0, right? I could pick all boys. I could have 1 girl and 3 boys. I could pick 2 of each. I could pick 3 girls and 1 boy. Or I could pick all 4 girls, no boys.
Zero is always going to be an option.
Yeah. You don't have to pick a girl. You could randomly draw and get 4 boys. So, what does at least one girl mean? Which of those outcomes is at least one girl? Right? At least one. I want to show you just how complicated just doing one of those is. The probability of picking one girl is going to be the probability that the first one picked is a girl, or the second one picked is a girl, or the third one picked is a girl, or the fourth one picked is a girl. And each one of those has their own probability. That's one of the easier ones to write. The probability of two girls. How many categories do I got? I could have girl, girl, boy, boy. I could have girl, boy, girl, boy. I could have girl, boy, boy, girl. I could have boy, girl, girl, boy. I could have boy, girl, boy, girl. Or I could have boy, boy, girl, girl. There's a lot of stuff going on here, like figuring out the probability of each. Each one of these little things is a different probability. Or, what is the complement of at least one? Zero, right? Zero girls. It's the only other outcome there. That's our complement. So we could, instead of doing, we could do the probability of zero girls, or I'm sorry, let me say it again. The probability of at least one equals 1 minus the probability of zero girls. Or another way of saying that is 1 minus the probability of all boys. This is drastically easier to calculate. As you will see tomorrow in 5.3. That's the end of lecture. You are free to get the fuck out. Or you could stay and work on homework, or you can ask questions. Does anyone have any questions before I hit stop record? Because I like having their questions in there. We're going to show you how to do this 1 minus probability of all boys tomorrow.